Question 1. There are only blue cubes, red cubes and yellow cubes in a box. The table shows the probability of taking at random a blue cube from that box. The number of red cubes in the box is the same as the number of yellow. We have to complete the table. Well, the probabilities here must all add up to 1. And as we already have 0.2, then if we do 1 take away 0.2, we're going to get 0.8, and that must be shared equally between red and yellow. So that would give us 0.4 in each case. There are 12 blue cubes in the box. Work out the number of cubes in the box. Well, if 12 blue represented a probability of 0.2, then if we times this right hand side by 5, we're going to get to the probability of 1, which is when you add all the probabilities together. So if we do the same to the number 12, we're going to get 60. So 60 cubes is the total number of cubes in the box. Question 2. Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar and twice as much butter as sugar. So Dion is going to make 16 biscuits. Work out the amount of flour that she needs. Well, 50 grams of sugar makes the 15 biscuits. And we need 3 times as much flour as there is sugar. So for the flour, we'd have to have 3 times as much as 50, which is 150 grams of flour. And that's for 15 biscuits. And it says twice as much butter as there is sugar. So the amount of butter needed would be twice as much as 50, which is 100 grams of butter. And again, that's for 15 biscuits. So we've got to work out the amount of flour that she needs. So if there was 150 grams of flour, I'll do this in a different colour. If there was 150 grams of flour for 15 biscuits, then to get 60 biscuits, which is what is needed, we're going to have to multiply in proportion both sides by 4. So we've got 150 multiplied by 4, which is 600 grams, and that will give us our 15 by 4, which is 60 biscuits. So the answer is 600 grams of flour. Dion has to buy all the butter she needs to make 60 biscuits. She buys the butter in 250 gram packs. How many packs of butter does Dion need to buy? Well, for 60 biscuits, you're going to need 4 lots of the 100 grams that were needed for 15. Because if you look up here, we had 100 grams of butter for 15 biscuits. So for 60, we're going to have to multiply both sides by 4 again. So for 60 biscuits, we've got 4 times 100, which is 400 grams of butter. Now they come in sizes of 250 grams in a pack. Now if she bought 1 pack, that would be 250 grams, that won't be enough. So 2 packs would be 500 grams, which would cover what is needed. So 2 packs would need to be bought. Question 3. Find the highest common factor of 72 and 90. Well, what I normally do is a table and I do prime factor decomposition. So I just basically find the prime factors of both numbers. So 72 is 2 times 36, 36 is 2 times 18, 18 is 2 times 9, and 9 is 3 times 3. So I have in order 2 times 2 times 2 times 3 times 3. For 90, I've got 2 times 45. 45 is 5 times 9, and 9 is 3 times 3. So putting these in order, I'll have 2 times 3 times 3 times, don't forget the 5. What I'm going to do now is compare these, and I'm going to see what factors they have in common. So there's 2, then a 3, and another 3. And that's under multiplication, don't forget. So you don't add them, you multiply them. So you've got 2 times 3 times 3, and that's going to be 18. And then you've got 2 times 3 times 3, which is 18 again. So the highest common factor is 18. Question 4. The diagram shows the plan, front elevation and side elevation of a solid shape drawn on a centimetre grid. So from the top we can see that it's a circle, and then from the front and the side we can see that it's the same rectangle. So this must be a cylinder. And we'll just do a sketch, doesn't have to be perfect. And what does have to be shown is that we're going to show the radius here as 2 centimetres. We're just going to put in radius so there's no confusion. We then though know that the height is 1, 2, 3, 4, 5 centimetres. And we can mark that very clearly on our diagram. Don't worry too much about trying to give dimensions for the circumference, because this part here, although it is curved, it will look like it isn't if you look at it dead on from the front or dead on from the side. So don't get confused with that. This dimension and this dimension is plenty, that's all you need to show. Some people might just put 4 and then put diameter in here instead, but I've chosen to just label the radius. Question 5. It says shape A can be transformed to shape B by a reflection in the x-axis followed by a translation CD. Well, let's look at the reflection in the x-axis first. So we're going to have a situation like 1, 2, 3, like so. And I'm going to call that A dash. So that's the reflection. And now we've got to do a translation, and we've got to find what that is. So if we look at this part here, we've got to correspond to this part here. So we're going to go back 1, 2, 3, 4, 5, 6 on the x, and then down 1 on the y. So what we're going to have in effect is a translation vector of 6 back on the x and then down 1 on the y. So C will be -6 and D will be -1. And what I've done on the diagram is just make it clear that distance there is 6 and that distance there is 1. Question 6. A shop sells packs of black, red and green pens, and it gives you some information here about how many pens are in each pack. So we've got the black pens, there's 2 in each pack. And the red, there's 5, and the green, there's 6. It then says on Monday there's a ratio of number of packs, so number of packs is in the ratio of black to red to green is 7 to 3 to 4. That's the number of packs. It says a total of 212 pens were sold. Work out the number of green pens sold. Well, if we look carefully, we can see that there'd be 14 black pens, because there's 7 packs and then 2 in each pack. 3 times 5, that'll be 15 red pens, and 4 times 6 is 24 green. So in terms of numbers of pens, in terms of a ratio, how many parts do we have? Well, if we add 14, 15 and 24 together, we get 53. If we times 53 by 4, we're going to get 212, which is what we wanted. So we'd have to times each of these by 4, so 24 times 4 is 96, 15 times 4 is 60, and 14 times 4 is 56. That would then make 56 and 60 and 96 add up to 212 pens sold, and to work out the number of green pens sold, well, that would then be 96. So 96 green pens sold. Question 7. We're given 2 rectangles. We're given some information. We're told that QR is 10 centimetres. And so also that BC and PQ are the same. We're told the perimeter of ABCD is 26 centimetres. That's all the way around here. And we're also told that the area of the second rectangle PQRS is 45 centimetre squares. Well, SR must be the same as PQ, and that must be 4.5, because only 4.5 centimetres multiplied by 10 would give the required area here, with 45 centimetre squares, which we're given. That means that PQ must also equal 4.5 centimetres, and we know that PQ and BC are the same, so this is 4.5 centimetres also. And then we also know that AD must be the same, because it's a rectangle, and importantly, the whole perimeter of ABCD is 26 centimetres. So if we take the number 26 and we take 2 lots of 4.5 away, then we've got 26 minus 9, which gives us 17. And that 17 must be the sum of the 2 missing lengths. And because they're the same, we just do 17 divided by 2. And that gives us 8.5. So DC would be 8.5 centimetres, and we wanted to find the length of AB, which is 8.5 centimetres. So AB is 8.5 centimetres. Question 8. Work out an estimate for the value of the root of 63.5 times 101.7. Well, if we write that out, then we can decide what our estimate's going to be, and something that we can do really easily in our heads. So I'm going to make the number 63.5 64, which is a nice square number, and I'm going to make 101.7 a nice square number as well, 100. So if I square root 64 times 100, that's the same as the square root of 64 times the square root of 100. We know the square root of 64 is 8, and the square root of 100 is 10, so 8 times 10 gives us 80. 2.3 to the power 6 is 148 correct to 3 significant figures. We've got to find the value of 0.23 to the power 6. Well, that differs in the way that if we divide 2.3 by 10, then we're going to get 0.23. So if we do that to the power 6, we've got 2.3 to the power 6, which we already know, we can quote, and we've got to divide that by 10 to the power 6, which is 1 with 6 zeros, which is 1,000,000. So we know the answer is going to be 148, and we've got to divide that by 10 6 times. So if we take the number 148, let's divide it by 10 6 times. So that's 1, 2, 3, 4, 5, 6. Let's get rid of this 0 here. So what we're left with is 0.000148, and that would be to 3 significant figures. And for part C, we need to find the value of 5 to the negative 2. Well, that's the same as 1 over 5 to the power 2, because when we have something to the negative power, then that means to find the reciprocal, which is 1 over the value, and so we'd end up with 1 over 5 squared, which is 25, so 1/25 would be the answer. Question 9. We want to work out 3 1/2 multiplied by 1 3/5. So first of all, we're going to change the 3 1/2 into halves. So how many halves are there in 3? Well, that's 6 and 1 more. That's 7 halves. We're going to do the same for 1 3/5, change it all into fifths. So we've got 5/5 in the 1 and then 3 more. So that's 8/5. When we multiply fractions, multiply the numerators and then multiply the denominators, and that's going to give us 56/10, which is equivalent to 28/5. Now, how many 5s go into 28? Well, that's 5 whole ones and 3/5 left over. And then we've got our answer as a mixed number in its simplest form. Question 10. We're given the equations of two straight lines that are shown on the graph, and we just have to find estimates for the solutions of the simultaneous equations. So all we have to do is look where they cross here. So you'd use a pencil and a ruler. I'm just going to use my pen. I don't have a ruler with me. So that's my x value, and then here is my y value. And now I'm going to look very carefully and see what those values are. So this goes up in 0.1, so 2.1, 2.2, between 2.2 and 2.3. So I'll go with 2.25. Seems to be halfway between them. And the y value, it's negative, don't forget. So negative 1.1, 1.2, about negative 1.3. And that's all we have to do for that question. Question 11. A bus company recorded the ages and years of the people on coach A and the people on coach B. It says here are the ages of the 23 people on coach A. So we've got to find the median first. So I use my little formula here, which is n plus 1 over 2 for the median. The lower quartile, I just halve that, so I have n plus 1 over 4. And the upper quartile would be n plus 1 over 4, but 3 lots of it, because it would be 3/4 of the way. So if you think about it in obvious terms for the median, if you had 23 objects put in order, which these are, you'd have 11 on one side, 11 on the other, which is 22, and you'd have 1 in the middle, which would be the 12th one. And you'd get that here. So if you let n equal 23, you'd have 23 plus 1 is 24, and then you halve it and you'd get 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 59 is the median. The lower quartile, well, you put n is 23 in here, plus 1 is 24, divide it all by 4, you get 6. So you'd have 1, 2, 3, 4, 5, 6. The upper quartile, n is 23, plus 1 is 24, divided by 4 is 6, and then times by 3, you would get 18. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It then says there's some information about the ages of the people on coach B. And we're given the median, lower quartile, upper quartile, the least age and the greatest age, and it says, Richard says that the people on coach A are younger than the people on coach B. Is Richard correct? We've got to give a reason. So I would say that the median on coach A is 59. The median on coach B is 70. And so I would say, yes, Richard is correct. And state 59 is less than 70, which tells you basically that the median was 59 on coach A, the median on coach B was 70, and because 59 is less than 70, Richard is correct. You'd have to give as much information as you can. For part C, it says Richard says that the people on coach A vary more in age than the people on coach B. So I would look at the interquartile range, and I would say the interquartile range, which is the spread of the 50% of the data. So the interquartile range for A is between 66 and 53. It's the difference between the upper and lower quartile. And so that would be 13 years. And the interquartile range for coach B would be 73 to 54, which is a difference of 19 years. So what we're going to say, we're going to say coach B varies more, so Richard is incorrect. Okay, because 19 is greater than 13. Question 12. There are three spheres, P, Q and R. It says the volume of Q is 50% more than the volume of P. So if we let X be the volume of P, then Q is going to be 50% more, which is 1.5 times more than P. So 1.5x. And the volume of R is 50% more again than the volume of Q. So we take the volume of Q, 1.5x, and we'd have to times that by 1.5 again to raise it by 50%. It then asks, find the volume of P as a fraction of the volume of R. So P over R in terms of the volume is going to be x divided by 1.5 squared x. Now 15 times 15 is 225, so 1.5 times 1.5 is going to be 2.25, and of course you can do that as a multiplication question in the workings. And then we cancel the x's on top and bottom. X divided by x is just one whole one. So that gives us 1 over 2.25, but if we don't want any decimals in there, then what we can do is we can double the bottom and double the top, and that will give us 2 out of 4.5, and then we can just double again. It's a useful tip to double if you've got a decimal at the bottom, especially if it ends in a 5. And so double the top would give us 4, and double the bottom would give 9. So 4/9 is the answer we're looking for. Question 13. It says, given that n can be any integer, n greater than 1, prove that n squared minus n is never an odd number. I think the way I would do that is to say, if we look at n squared minus n, and if we factorise it, then what we're seeing here is a number n and 1 less than n. So they're consecutive numbers. And if you look at the consecutive numbers, and so on, now n's got to be greater than 1. So if we look at, say, n being 3, n minus 1 would be 2, and 2 times 3 is 6, which is even. In fact, if you look at all of these numbers that are consecutive, 3 4s are 12, 4 5s are 20, they're all going to be even, never an odd. But if you want to conclusively show that, then if you let n equal, say, 2m plus 1, which could be an odd number at that particular point, because 2m is always even, and if you add 1 it's odd, then n minus 1 would have to be 2m. So if you look at this expression here and you just put in 2m plus 1 and multiply it by 1 less, which is 2m, then can you see what's happened here? If you switch these around, you're going to have 2m lots of 2m plus 1, and no matter what happens, this expression here is always going to be multiplied by a 2, which will make the expression even. And you could have said this by looking here and saying, look, you've got 3, we're timesing it by an even, so it's going to be even. You've got 3 again, you're timesing it by the next one, which is 4, which is even, so you're going to have to get an even. But this algebraic way shows you that you're always going to have 2 lots of some expression, which is always going to be an even answer. Question 14. For those that know the values of tan 30 and sine 60, I'll just do this very quickly. And so tan 30 multiplied by sine 60. Well, tan 30, for those that know, is root 3 over 3. And sine 60 is the same as cosine of 30, which is root 3 over 2. Root 3 times root 3 is 3. 3 times 2 is 6. And 3/6 is 1/2. So 1/2 is the answer. For those that forgot or forget the values of tan 30 and sine 60, then if you want to have angles of 30 and 60, you can do this from scratch. That's just in case you forget. So you start with an equilateral triangle, which of course has angles of 60. You do a perpendicular bisector, so you've got an angle of 30, which is what you need. And if you just call the lengths of this triangle 2, then these are going to be 1 because it's a perpendicular bisector. And just look into one of the right angle triangles and you can use SOHCAHTOA. And so, for example, the sine of 60 will be opposite. Now, in this right angle triangle here, you can use Pythagoras, so 2 squared minus 1 squared, well 4 minus 1 is 3, and then we have to root it. So sine of 60 is going to be opposite, which in this case is root 3 over hypotenuse, which is 2, and that would give us the root 3 over 2. And if you wanted tan of 30, then you just say, okay, tan of 30 is going to be opposite, which is 1 over adjacent, which is root 3. And for those that know how to rationalise the denominator, you just times top and bottom by root 3. So you're going to get root 3 over 3, which is again what we said it would be if you could remember these by heart. Okay, if you have angles of 45, for example, then just draw a square, label these sides 1, do your hypotenuse, and then you'll have an angle of 45. And again, you can use SOHCAHTOA to actually prove sine, cosine of tan of 45. Okay, so if you knew that, you can just skip forward. If you didn't, then there are a few hints for you in the exam. Question 15. We're given the diagram which shows a solid shape. It's made up of a cone on top of a hemisphere. We're given the height of the cone is 10 centimetres. The base of the cone has a diameter of 6 centimetres, and the hemisphere has a diameter of 6 centimetres also, because they're joined together. And it says the total volume of the shape is k pi, and that's made by adding the volume of the cone plus the volume of the hemisphere. So that means k pi is equal to, well, the volume of the cone is a third times pi times the radius, which don't forget is half the diameter, so that's 3 squared times the height, which is 10, plus the volume of the hemisphere is half the volume of what the sphere would be. And then we just have to work these values out carefully, do some cancellation. So I'm going to just do this really carefully here, one bit at a time. 3 squared is 9 times 10 is 90. That's 4 over 6 times pi times 3 cubed is 27. I'm going to divide both sides by pi. And that's going to give me, just get a bit more room, and that's going to give me k equals 3's into 90 is 30. 4 6 is 2/3, and 3's into 27 is 9, so I've just got 2 times 9 here, which is 18, and therefore k is 30 plus 18, which is 48. Question 16, we're given a combination lock, and it says that each dial can be set to one of the numbers 1, 2, 3, 4 or 5, and we're given 5, 5, 3 on the combination lock as an example. It says work out the number of different 3-digit numbers that can be set for the combination lock. Well, we're going to have 5 choices for the first, 5 choices for the second, and 5 choices for the third, which is going to give us 5 cubed, which is 125 choices altogether. Part B, it says how many of the possible 3-digit numbers have 3 different digits? Well, think about it this way. For the first position, you would have 5 ways, because it doesn't really matter which number you put in, you've got 5 choices. But for the second, say for example you chose a 1 in the first place, you couldn't choose that again. So you could choose anything but 1, so there'd only be 4 ways, and that would be the case if you start with a 2, a 3, a 4 or a 5, you just couldn't choose that number again. Now for the third choice, say for example you chose a 1 first and then a 2 second. For the third choice you couldn't choose a 1 or a 2, so you'd only have 3 choices left. And you'd multiply those together, and that would give 5 times 4 times 3, which is 60 choices. And let's just see how many marks that was worth. That was 2 marks also. Question 17. We can see that x squared to 3x plus 5 as a ratio is the same as 1 is to 2 as a ratio. So if we can make this side 1 by proportionally dividing both sides by x squared, then from here we're going to get 1 again is in the ratio to 3x plus 5 over x squared. So from here you can now say, because they're both in the ratio to 1, that these two things here are equal. So we can say that 2 is equal to 3x plus 5 over x squared multiply both sides by x squared, so we'd get 2x squared equals 3x plus 5. Take 3x from both sides, then take 5 from both sides, and we'd have 2x squared minus 3x minus 5 is equal to 0. We'll see if this factorises. So we'll have 2x and x, and then we'll have factors of 5 and 1, and if we do the other way round actually, so let's have a look. If we put the 1 here and the 5 here, and we make this a plus and this one a minus, let's see what we'd have. We'd have 2x squared, we would have plus 2x minus 5x, which gives us the minus 3x, and then minus 5 times plus 1 is minus 5. So what we can say is, solving this bracket equal to 0, we'd have x equals 5 over 2, and solving this one equal to 0, we would have x equals negative 1, and they're the values of x that we want. Question 18. We want to express root 3 plus root 12 into this form, a root 3, where a is an integer. So 3 is a prime number, so it doesn't have any square factors. 12 does have square factors. It's root 4 times root 3. And so that's the same as root 3 plus 2 times root 3, which is root 3 plus 2 root 3, which is going to give us 3 root 3, and that's the answer to the first part. For the second part, it says express 1 over root 3 to the power 7 into this form. Well, don't worry too much about that. I personally would rationalise the denominator of 1 over root 3, so times both sides by root 3, and so that would be root 3 over 3 to the power 7. And I think for those that know this really well, I could just write some very simplified workings and get to the answer really quick. But for those that struggle with this, I'm just going to do it slightly longer, so you can skip forward if you want. So I'm just going to write this out 7 times. It's not going to be too much. And I'm just going to have 3 to the power 7 underneath. Now the nice thing about this, and when you get used to doing these, you can do it much quicker. Every time you see a root 3 times a root 3, you can just write 3. So we're going to have 3 times 3 times 3 times root 3. And then underneath, you've got 3 to the power 7. Now if you look carefully, you've got 1, 2, 3 powers of 3 here, which will cancel with 3 powers of 3 here to leave us with root 3 on top, and then 3 to the power 4 underneath. And 3 to the power 4 is just 3 times 3, which is 9, times 3 times 3, which is 9. And so you get 9 times 9, so underneath you're going to have root 3 over 81. So try that question again. Maybe you can do it without rationalising the denominator and see if you get the same answer. You'll probably have to do some rationalising the denominator at some point, but give it a try and see what you get. Question 19. Given that x squared minus 6x plus 1 is the same as writing x minus some value of a all squared minus some value of b, then we just need to look on the left hand side. I'm going to complete the square. So there's my square completed. You always halve this value here. And then I've got this situation. Now how did I get here? I'm not going to go into a massive amount of detail, but if I did x minus 3 and I squared it, you'd have x squared, you'd have a 9 here, minus 3x, another minus 3x. So you'd have your x squared, you'd have your minus 6x, and then you've got a 9, which you didn't want, and that's why you would take this 9 away, and then the 1 was just there anyway. So you can practice that technique of completing the square, but I'm not going to go into a massive amount of detail now, or else you'll get complaints. So I'm now going to look carefully at the left and the right hand side, and I can see here that A is 3 by comparing, and I can see that B is 8. Now it says, hence, write down the coordinates of the turning point on the graph of x squared minus 6x plus 1. And again, if you think about this, when you've got graph transformations, if you look at y equals x squared minus 6x plus 1, and you were to plot it, knowing from part A that the form is like so, to find the turning point would be either the maximum or the minimum. Now, because this coefficient of x squared is positive, i.e. it's just a positive number of x squared, the shape's going to be like so. So it's going to have a minimum point. And the minimum value of this right hand side is always going to be where this bracket vanishes. Okay, so that would only happen when x is 3. So I know it's going to happen when x is 3, and when that bracket is no longer there, and again there's a lot of detail in explaining this whole notion of turning points, but when you actually minimise that expression, that bracket will vanish and you'll be left with y is equal to minus 8, and that's the y coordinate. So I'm just going to put that in. So be careful, it's not just going to be the same as part A, it's going to be minus 8 in this particular form. So give it a go. One good site that I use is Desmos, where you can interactively plot functions. It's a really good site, and if you just put this function in, and then if you put this function in, y equals x minus 3 all squared minus 8, then you can have a look and see what the graph looks like, and you can convince yourself that this is the turning point. Question 20, we have h is inversely proportional to p, and p is directly proportional to root t. So the first one would mean that h would be equal to k over p for some value of k, and p would be equal to, now be very careful, don't use the same k as we had in the first one, just call it L or K1 or capital K. I'm going to just call it L. Now we're given some information, as we always are in these questions, and we're given when h is 10 and t is 144, p is 6. So for the first one, if h is 10 and p is 6, we can find k by multiplying both sides by 6. And then we can say that h is equal to 60 over p, because we've found the value of k. So we'll put that one to one side. For the second one, p is 6 still, and it says t is 144 when p is 6. So we have L root 144. 144 is 12 squared. So that means 6 is equal to L times 12. Divide both sides by 12, which would mean that L is equal to a half. So we can put that in here, and we'd have P is equal to a half of root T. Now, the question says we want to find a formula for H in terms of T. So what I'm going to do is I'm going to notice there's a P here and there's a P here. So there's two ways of doing this. I can either get P as the subject to the formula in both. I already have it as the subject here, and then I could make it the subject here and then equate what's left. Or I could just do a substitution. So I'm just going to do it, I think, by substituting. So I'm going to say if H is equal to 60 over P, but P is also root T over 2. Now I can multiply numerator and denominator by 2, because if I times top and bottom by 2 over a fraction, the value doesn't change. So I would have 120 over root t, and that would be one possible answer you could give. For those that don't like a root t underneath, you can just say that's 120 over t to the half, and you can just say, well, that's 120 t to the minus a half. So I will just put a tick by the two that I think would be fine. Those two would be perfectly acceptable. Question 21. The functions f and g are such that f of x is 3x minus 1 and g of x is x squared plus 4. We want to find the inverse function of f of x, which is f minus 1 of x. So the way I do this is I let y equal 3x minus 1. I do the inverse operations to find x as the subject, as opposed to having y. So I will add 1 to both sides. And that will give me y plus 1 is equal to 3x. I'll divide both sides by 3. And that will give me y plus 1 over 3 equals x. And then I say to myself, well, an inverse function, f minus 1 of x and f of x, if I plotted these on the same graph, they would be mirror images of each other in the line y equals x. So in this case, if I write this out again, and all I have to do is interchange this y here for x, and by doing so, this becomes the inverse. So the inverse function f minus 1 of x is just x plus 1 over 3, which is really just rearranging this for x. Now, let's look at part B. It says f of g of x is twice g of f of x. So f of g of x means f takes on g of x. So we look carefully here. So we have 3 lots of x, but that's where you put g of x in its place. And then we have minus 1 equals twice, and then g now takes on f of x. So wherever we see an x here in g of x, we would have to put 3x minus 1 instead. And that's squared, because we had x squared here, plus 4. So just look at that again. F takes on g of x, so f is 3x minus 1, so 3 lots of g of x minus 1, and that's equal to 2g takes on f of x, that's 2 lots of, now g of x is x squared, so it's going to be this f of x all squared plus 4, because we had a plus 4 here. I now need to multiply all of this out, and we're looking for 15x squared minus 12x minus 1 is equal to 0. So let's see what we get. Let's give ourselves a bit more room. So here we'd have 3x squared plus 12 minus 1 equals 2, and I'm going to do a square bracket here. I'm just going to write this bit out again, just so you can follow what I'm doing. I don't need this bit here. So I just used a square bracket and a curly bracket to show the difference. Makes it a little bit clearer. So the left hand side is going to stay the same, but this right hand side I'm going to do this bracket first. So square the first, square the last, times the two bits together and double. And if you don't like that, just do 3x minus 1 times 3x minus 1 in a grid. So it is like squaring the first, squaring the last, and then because you've got minus 3x, which is minus 1 times 3x, you've got that doubled up, and that gives you the 9x squared minus 6x plus 1. And then clear up this bracket here. And then multiply out. So we've got 18x squared minus 12x plus 10. Rewrite in the left hand side here, because 12 minus 1 is 11. And then I'm going to get everything on the right hand side, so I'm going to take 3x squared off both sides, and that's going to give me 15x squared. The minus 12x there is already waiting for us, and I'm going to take 11 off both sides. And that's going to give us 15x squared minus 12x minus 1 equals 0, which is what we had to show here. Question 22. It says there are only red and green counters in a bag. A counter is taken at random from the bag, and the probability that the counter is green is 3/7. So the probability of getting a green is 3/7. But how would we get a green? Well, it'll be how many green out of the total, which is some number of red and green combined. So that's the first thing we need to look at. And the counters put back in. It says 2 more red counters and 3 more green counters. So there's going to be 2 more red and 3 more green in the bag now. And it says the probability of getting a green is now 6/13. But there would be G plus 3 green out of a possible R plus 2 plus G plus 3. And that's the same as 6/13 is equal to G plus 3 over R plus G plus 5. Because don't forget, I've got to add this 2 and the 3 together. So looking at these two here, all I need to do is solve these equations simultaneously, and that will give me the values of R and G that I need, because it says find the number of red counters and the number of green counters that were in the bag originally, which is just the value for here, R, and the value for G. So let's give ourselves a bit of room. In fact, what I'll do is I'll work on the right hand side here. So from the first one, if 3/7 equals G over R plus G, I'm going to multiply both sides by R plus G, and then multiply both sides by 7. Multiply out, so 3R plus 3G equals 7G. Just make sure these G's don't look like 9s. If they do, just make it a capital G instead, okay, because you don't want to be getting confused. I'm going to take 3G from both sides. So I'm going to say that R is equal to 4G over 3, so I'm just going to divide both sides by 3. So R is equal to 4G over 3. And I think what I'm going to do is, I think I'm just going to substitute that straight back into here. For those that can't, what you need to do is just work with the second equation the same way you work with the first, just multiplying things out, cross-multiplying, and then get R in terms of G, but you can just substitute straight in. So I'm just going to have 6/13 is equal to G plus 3 over R, which is 4G over 3, plus G plus 5. And then I'm just going to clear up the denominator a little bit. Well, this is 4/3 of G, and this is 3/3 of G, which is 1 whole one, so that's 7/3 of G plus 5. And now I'm going to just multiply out by cross multiplication, which is really a technique. What you're really doing is timesing both sides by 7G over 3 plus 5, and then by both sides by 13. So we'd have 7g over 3 plus 5 multiplied by the 6 and then times both sides by 13. And then we just need to multiply this out and let's see what we get. So we've got 42g over 3 plus 30 equals 13g plus 39. And 3's into 42 is 14, so we've got 14g plus 30 equals 13g plus 39. You can see here, and these annoying 9's and g's could look the same if you weren't careful. Take 13g off both sides, and that's going to leave us with g plus 30 equals 39. Take 30 from both sides, and that means g is equal to 9. And if we look carefully, we had here, I'll write in a different colour, we had here that r was always going to be 4g over 3. So if we know g is 9, then that means r is going to be 4 times 9 over 3, which is 36 over 3, which is 12. So r is 12 and g is 9, and that was the original amount of red counters and green counters in the bag at the start of the question.